Hello everyone. So in this session we go through the topic of paired samples t-test in our studio, and you can find the supporting text material on the page mystats.online, and also the data for the exercise which are taken from the R book and are also located behind the link data on the webpage mystats.online. So if two samples are paired, it means that there is a correlation between these two samples. And if there is a correlation between two samples, then if we perform a test, we call this test paired samples t-test. So the paired test has every time bigger power, of course, than the unpaired test, and type 1 error is a function of correlation for the paired test as expected. So we can go to the exercise and we can create our file and save it into the object streams. So streams and then read CSV, and then I have saved my file into the documents and my analytics folder with the data. Let's have a look. How does the file look like? So view streams, and we can see that we have 16 observations and 2 variables up and down. So let's calculate. The first what we could calculate is the correlation, and let's first write the function attach so that we can work with the data, and then let's calculate quickly the correlation between the variable down and variable up. So we can see that the correlation is very, very close to 1. So it's almost perfect correlation between these two variables. And what is the correlation? Correlation is a covariance divided by geometric mean of the two variances. So let's create a graph of these two variables, down and up, and see this correlation also graphically. So let's create, because we have 16 observations, let's also include into our data our order, which would be from 1 to 16, and we can see that it would be just these numbers. Or let's save into the dependent variable, or variable in our case epsilon. Let's save the variable up, and into our, let's call it R epsilon or Z if you wish, axis. Let's save down. And now to display nicely down and up, let's install the package plot rix. So tools, install packages, plot rix, install package. Okay, library plot rix, and the word dot plot epsilon x epsilon x r y. Okay, so that's the basic plot on two axes. So axis epsilon and axis z, or if you wish r y. So this is showing that the correlation is really very strong, and we can just perform the paired t-test. We can perform either the paired t-test line by line, or x or down and up separated, or we can create straight away the difference between down and up and compute the one sample t-test. So let's create, for example, the one sample t-test, and let's calculate the difference between down and up. So, and let's call it difference. Difference is our special object created to perform the one sample t-test. So up minus down. Difference up minus down. Let's see what are the exact values of the difference. Okay, and now we can easily create a t-test of the difference. So we can see that the p-value is extremely small. It is 0.0081, and which is much smaller than 0.05 confidence interval, and that is why we can say that these two variables, down and up, are significantly different. So that was the paired one sample t-test. So thank you very much for your time, and I hope that it was helpful for you, and I hope that you will join the next session. So this was the paired